Now we will focus on the peak of the graph. Go back to the Atmospheric Profile tab and reset the atmospheric profile to tropical. Next, return to the graph for just the tropical conditions. Look at the peak of the plot. Estimate a range of wavelength about 4 microns in size, covering the extent of the peak. Go back to the Run Model tab and change the range of wavelength to this smaller range. Change the size of the step to 0.025 and choose a new name for the run. Run SB-Dart again to generate more detailed information. In the Plot Model Runs tab, remember that when you view a plot, you can also view information about the model run in the lower right scroll window. Look over the information given for your most recent model run, the high resolution of tropical. Scroll down until you find the flux reported by increments of the wavelength under SB-Dart output. Look for the largest flux value. The wavelength at which this flux occurs is called the wavelength of peak emission. Find the wavelength or wavelengths of peak emission for the tropical atmospheric profile. If there are multiple wavelengths with the same flux, calculate the average wavelength. Simply use the middle value if you have an odd number of pairs. Record your answers in the table below question 7. Repeat these steps for either mid-latitude summer and subarctic summer, or mid-latitude winter and subarctic winter.